But before we can do that, we kind of need to understand a little bit about how MySQL works under the hood. Because honestly, understanding it requires that. And a lot of the stuff kind of becomes very apparent once you do understand these pieces. I will try and make it very light. I'm not going to go into too much depth. There is a lot of complexity when we dig into something as monolithic and enterprise-y as MySQL, and with a number of add-ons and exceptions and cases. So I'll try and keep it fairly high level, but it should still be, hopefully, interesting for some of you. And then if you're not all bored to tears by the end of that, I will talk about some cool tools you might not be aware of, or may be aware of, that you could use to make your life a little bit easier. So why am I up here talking about MySQL? Well, yeah, so my journey of getting to know MySQL very intimately started because, well, I work for Booking.com, and we have been told we have contracts with Oracle, who's obviously the current owners of MySQL, and because we're a big company, we have big databases, and we keep getting told by their consultants, yeah, you guys have a lot of tables. We currently have a system that looks exactly as you would imagine it if you took 2,500 developers, gave them no guidance, instructions, rules, threw them at the database and said, have fun for 10 years. We now have in the region of 200, I did a count before I came today, we have over 290,000 MySQL tables right now. We are pretty sure it's the world's biggest installation and deployment. So I was told, try and make sense of it, please, which was fun because, yeah, 290,000 tables with no meta information and a whole bunch of people using different rules of how to do something was quite an adventure. And this is also one of the reasons why I now have gray hairs, the other being kids. So, of course, I'm only up here not because I'm a smart person or I have some incredibly specific knowledge or I'm some form of MySQL database engine whisperer. It's mainly because I've had the very distinct pleasure of working with some really smart people. So I wanted to point out a couple of them. There are plenty more, but in particular Shinwoo, who is now, has unfortunately left us and is now working for GitHub as one of their staff engineers. Simon Mudd, who, if you've ever had to work with MySQL NDB, distributed node MySQL installation, he pretty much wrote most of it. And Chris Krontorp, who is one of our principal system engineers at Booking at the moment. And you probably have read stuff he's written online. He tends to crop up in places like the Yellow Hell site or Reddit. You just don't necessarily know it's him. So let's see if class is paying attention. What is wrong with that table? I'll give you a few minutes to think and digest. One thing I really missed about doing everything virtually, for the first time, I can get some audience interaction.
Prime key missing.
Prime key missing. That's a good one. That's a good one. Anyone else want to take a shot? I can't see the online chat, so if anyone wants to... Oh, no, didn't see that.
Okay.
Yeah, so there's nothing specified null or not null. What is it by default if you don't specify it? Yeah. Come on, since PHP gets such a bad rap around security, come on, someone please point out this one.
Oh yeah.
Well, if you decrypting your password, it's going to be a static length. It's always going to be the same length.
Yeah. So
you should have a char and the char for the length of what that is, and it's definitely not 72. All right.
Are names really going to be 300 characters?
There's an entire list of myths we think about names and how we can get them wrong. So I'm not even going to try with that one. However, here are a couple of things we could have mentioned. Primary key, you got that. The fact that we were using the join date was time, date time, where we could probably use a timestamp unless they joined before 1970. There were other fields that there were a timestamp that could have been a date. Should we be using varchar or char in certain circumstances? There are no indexes. Well, there was an index, but it's hidden. Terminology. We'd call the table users or user. What is the preference? Why do we choose one or the other? We had a language in there, but should we be referring to locale and not language? There is a distinct difference there. We had a big text field for address. Maybe that should be broken down and normalized into multiple fields for easier parsing for backend systems. We didn't have any defaults or nulliness or the email length. That's a good one. How long is an email? What's the maximum length of an email? There's an RFC. There's actually 3 RFC. They all contradict each other. There's only one that matters.
The longest one, right? The one that allows most data.
No, it's the shortest one. Actually, the one that really matters, there's an RFC for emails, there's an RFC for domain MX records, and there's one for SMTP. And SMTP is the one that matters because it doesn't matter what the other two say. If you can't send your mail, it doesn't get anywhere. So it's 254 characters. Yeah. And then there's also all sorts of oddities like the fact that Google will strip out all the dots that you put in an email address. So you can actually have a longer one or do the tagging where you do a plus and add a tag. So you can actually have an email address longer than that, but only Google will accept it and some mail clients.
Well, it's part of an RFC, so any email as a email service should accept it.
So SMTP will strip the tagging first, and then it will accept up to 254, and it's a mess. Bcrypt is 60 characters long, not 72. Yeah. So I'm not going to talk about all of that because we don't have enough time, and also because some of it's really boring, and also some of it's quite religious, especially when we start dealing with times and date times and the like. Because that generally, what I suggest to anyone if you're dealing with time is whatever your DBA says you go with, because they're the ones who have to deal with things go horribly wrong with daylight savings, time zones, or any other horrors, and even a booking. Every year when the daylight savings change in different parts of the world at different times, sometimes with a day's notice, thank you, Russia, things will break. Graphs will suddenly have truncated data or overwrite existing data, and it's horrible. Grafana is very bad at this. So I'm going to focus on primary keys and indexes because they're fairly closely related, and they're fairly important for a lot of the work we do. And understanding them brings a lot of understanding of some of the other problems we have. So my first question to you is, does this table have a primary key? Who wants to hazard a guess?
Is it a trick question?
Yes, it is a trick question.
I'd say yes then.
Well, we should probably ask is, what's the primary key? What engine is this table using?
ISAM by default or either the
So depending on the table, it does what engine? So MySQL engine. So MySQL is made up of a bunch of pieces. One of them is how the table gets stored and how you access data in it, and that is the table engine. You have the query parser and the query validator and so forth, but the how the table is stored and how it's accessed is managed by the engine. Each table can be specified for a different engine. Now, there's a couple. There's MyISAM, which was the original MySQL one. There's InnoDB, which is now the default preferred one for a while now. There's memory, which literally says any content you put into this table goes into memory, and when you restart the server, it all goes away, which is useful if you want to do logging and you wanted to get rid of it, kind of flush it out when your server restarts. And then there's black hole, which literally says, give me data and I'm going to pipe it to dev now. And there are valid use cases for it. Not a lot, but there are. So if you're feeling particularly evil, you can create a table like that and see how long it takes your peers to figure out why their data keeps disappearing. I wouldn't necessarily recommend it. It's not going to make many friends, but yes, that is something you can do. So yeah, the two that are really relevant is MyISAM and InnoDB, and choosing which is a difficult task. And let me explain why. So InnoDB supports ACID compliance. Now, this is very, very important if you're dealing with something financial, something very high risk that you cannot lose the data. which means you need the data to be done atomically, consistent, isolated, and durable. This is a basic test for data integrity. So InnoDB has that. It means also it supports things like transactions, which is also very important for financial stuff. You need to do a bunch of changes, and if something fails along the way, you need to roll them all back in one unit. InnoDB also has row-level locking, which means if you update a specific row, you only lock that one from others being able to read it, where with MyISAM, it locks the whole table each time you change any data in it. Yeah, MyISAM used to have faster reads. So if you go on Googling online and say, yeah, if you want to do high reads, you should use MyISAM, that was applicable 8, 9, 10 years ago. That is no longer the case. MyISAM's development stopped. InnoDB is now faster reading. The development on it has brought it past MyISAM. So there is no reason to use MyISAM anymore. In fact, the default has been InnoDB since 5.4, MySQL 5.4. So if you are using MyISAM, in fact, you can go and run that query on your database right now. You probably want to recreate that table using InnoDB, because generally that's a good idea. Oh, by the way, if anyone has any questions online as well, are you watching online? Okay. Vim will let me know if there's any questions, but if anyone has any questions, stick your hand up. I don't mind stopping and chatting, as long as we don't delay my snacks too long, because I haven't had supper yet. And I get cranky. So back here, let's assume this is InnoDB. So what is the primary key here? Is there a primary key? So if you do not specify a primary key, InnoDB goes on a quest to find one. The first thing it looks for is any field that is not nullable unique, and it will make that a primary key in the background. It won't tell you it's a primary key, but it will make it the primary key. It's not great. So what it actually does is it creates something called a clustered index. Now, normally when you deal with InnoDB, the clustered index is the primary key. So there's synonymous. But if you do not specify one, it will create one in the background, and it will use the email address in this case. If it cannot find a non-null unique field, then what it will do is it will go and create an auto-incrementing ID field in the background, not show you it exists, and make that the primary key. So if you think you're saving space by not creating a primary key, yeah, still creating a primary key that you can't even use. So set a primary key. And there's even lots of documentation. By the way, I've shared the slides in the chat, so if anyone wants to follow along, and I do provide references for why I make these wild statements. You can actually find out if any of your tables currently have one of these imaginary, these hidden ID fields by running that query. You cannot fix this by adding a primary key to your table. You will need to recreate the table from scratch. So just be aware. Because you're still dealing with the cost of storing the ID. You're still dealing with the cost of updating that ID every single time the index changes, but you can't use it. So it is wasted space, and I would recommend actually adding it. There's also a whole bunch of other complicated things that can go horribly wrong without a primary key. So InnoDB inserts use a mutex lock inside. Doesn't matter too much if you know what a mutex is or isn't, but what it pretty much means is if you throw a lot of inserts at it and you don't have a primary key, you're going to have a bad time over time, especially under high load. It'll get exponentially slower, especially when you're doing inserts to multiple tables with a transaction. Get a primary key. If you're using binary logs, you're going to take up a lot more space, because every single time it needs to tell you whether it's deleting a record, it can't just say using this ID. It has to literally say the entire record, what you're deleting, to be explicit. If you're doing replication via binary logs or bin logs, you're going to have a bad time. Once again, same reason, but also from MySQL 8, you're going to break your replication. It won't actually work unless there's a primary key specified. So if you don't have any of those tables and you think, let's just update to MySQL 8, you're in for a bad time. And finally, if you're using something really complicated like clusters, InnoDB or anything like that, yeah, it's just not going to work, and you're going to have a bad time. So generally, the best suggestion I can give you is make sure you have a primary key. It saves you a lot of hassles, a lot of weirdness that you didn't think about or didn't expect. Make sure there's a primary key. In fact, from MySQL 8, there's this handy little variable you can set on your database that prevents anyone from creating a database a table without a primary key. So if you're a system administrator or someone with kind of this kind of leverage, make sure you go and set that. I think this is actually from version 8.0.13 onwards. So that's primary key settled. Does anyone want to contradict that? Everyone's going to create tables with primary keys from now on. Fantastic. Your DBAs will be very happy with you. Let's talk about indexes now, because I think that's the next thing that's quite important for a lot of people is fast databases. Databases are fast as long as we don't abuse them. But to understand how searches work, we are actually going to have to get technical now. And I apologize. Does anyone know how MySQL stores its data internally? At least for InnoDB, because we're explicitly talking about InnoDB right now. So this is ripped right from their website. How MySQL stores it is interesting. You have your clustered index or your primary key index, because they should be the same. And that contains a whole bunch of data showing where your fields are stored. And then you have the actual data. So the idea is if I give you an ID, you should be able to let's say your primary key is an integer. If I give you, go get me this record, it should be able to very quickly find it and then reference the data that it points to. And that's all hunky-dory, and that's a very simple way of working. And then secondary indexes, which you build to kind of make it faster to search on other fields besides your primary key, have their own on the side here. And they will run through the same process, but then they will get the primary key value and then go over here and run through this. So when people say your primary key lookup is always going to be faster, it's because it's not having to go from here to there and back down again. It's just going straight here. So indexes are faster, but they're not as fast as using the primary key. If I run a query and I can't use the primary and I can't use a secondary, then it literally has to go and look through every record in here. And that's called a full table scan. And that is bad if your table's big. Everything here conditions on the fact that everything's fine until your data starts growing. And that's generally when you see things go horribly wrong. Now, this data structure here is interesting. And it looks a little bit like this. And I apologize for the low-res picture, because I wasn't going to recreate this in Draw or Paint or something. But the basic idea is this is what's known as a balanced tree, not a binary tree. You might be thinking, hey, I finally have a use for creating and navigating a binary tree. This is not a binary tree. This is a balanced tree. What a balanced tree does is it tries to balance the number of records in each collection with how deep the tree is, and trying to find the best balance so you can very quickly find something in the tree as performantly as possible. So it doesn't matter if it's millions or billions of records, it should be only a few operations to get to that record. And it does this by expanding its node sets or by increasing its depth. So what happens here is, let's give a quick example. These are for instance, your primary keys. So these are the integers, and these are the references in memory of where that row is. So if I say I want row where some value is 55, that's the record there. I can go into my memory, literally pull out that record, and there is my row of data. In this case, it's not actually a primary key because they've got duplicates, but let's say age or some meaningful number. And how this works to navigate is quite cool. So let's say I want to get any record that begins with, that is 57. And what it does is it starts off at the beginning and it goes, right, first record 39. Is the number I'm looking for less than or equal to this? No, cool, go to the next one. 83, is that less than or equal to 50, is that greater than or equal to 57? Yes, right. Follow it to its next collection. Right, I got 46, 57, no, next one, 53, no, 57, fantastic. There, and it finds the first record, and then it can carry on until it doesn't match anymore. And that's to find 1, 2, 3, 4, 5, out of 6 records, 1, 2, 3, 4, 5, 6, 7 operations. Now, that doesn't sound particularly performant, but that's also because it's not showing that one's node set and that one's node set, and then all the node sets of these other ones. So as an example, if you have 10 depth and each set has 10 numbers in, you can store something in the region of 1 trillion results. And the maximum cost it'll take to get to any particular entry is 10 times 10, which is 100 operations.
Would you recommend using a UID as a primary key?
There's a whole conversation there around UUID, and that I'll say let's talk later. No, because there's a lot of interesting things there. Everything from the fact that how it stores. Okay, if we have time at the end, I'll talk about that because that's a really fun topic. What InnoDB does to try and be as performant as possible is it tends to take these high-level nodes here and keep them in memory. And so you can very quickly operate through those ones, and then the lower-level ones they keep on disk. So finding your data is actually normally only 1 or 2 disk operations, but a lot of stuff in memory. And so when you end up with a table that's maybe you've just restarted your server, all your caches are cold, your first query is going to be slow. But almost immediately after your first query, the next queries are going to be very fast because it would have loaded all of these layers into cache. So depending on how big your database, sometimes it makes sense when you restart your server to just run a bunch of queries on it that you know is going to be running your server to kind of warm it up. All right. Yeah, so it doesn't balance it exactly number of depth by number of leaf nodes. It depends on how big your indexes are. If you're using strings versus numbers, you can pack more in if there's numbers. But there's also a balance between how many per node versus how deep to get the best performance. But the basic idea is in this case, I just went n times n is how many operations to find the worst, and n to the power of n is how many records you can store. So as you can see, you can very quickly, out of billions of records, find, and that's the worst case, by the way. So it has to go through every single layer all the way down to the bottom. It's actually really cool. And in fact, the B tree, they don't use B tree, they use B tree plus, and that has all sorts of other cool little optimizations and the like. You might ask, if you want 1 billion rows, you only really need a tree depth of 5, which is quite crazy. Yeah, it depends on how many keys you can fit in. There's reasons, there's descriptions there. You can go and read up. There's a lot of maths there and a lot of reasoning, but it's really cool. Did I actually add that in? I realized I tampered with my slides, which is what speakers should never do right before they talk. You might be thinking, hey, why aren't they using a hash lookup? Because hash lookups are really quick. Why don't I just use a hash lookup and then I can find my record in near constant time? You can actually specify using a hash as an index for certain table types, but it only works if you're looking up the direct value. The second you want to do a fuzzy match, the second you want to do a range lookup, it doesn't work at all. So the balance tree is kind of the best cost optimization for a bunch of problems. You could have a hash lookup and a B tree lookup index, but then you're also compromising on space and keeping them updated. So all in all, the balance tree seems to be the best balanced choice for performant index lookup. Any questions about that? Yeah, all right. So when you run a select, you might also not know this, is what happens when you run a query is there's an engine inside MySQL that tries to decide what is the best index to use. And generally, it's way better at doing that than you. So generally, you do not want to tell it, actually don't use that index, use that yellow index, because it normally has a lot of reasons why it uses one or the other. That being said, I'm going to teach you how to, oh, no, this is something else. This is actually a nice side effect of how indexes work in InnoDB. So if I create that table, simple table, give it 2 fields, and I create an index, field 1 and field 2, and I run a query where I go, yeah, select star from simple table where field 1 equals something, it'll use that index. And it'll use that index, and then it'll go and look up, based on the primary keys it finds, look up through the primary key index, and then get the records and return the results. And that's pretty straightforward. And the same if I do a count star on it. What is interesting, though, is if I do this, it doesn't have to do anything after it's looked up the index. It doesn't have to go to the primary key or the clustered index, and it doesn't even have to look at the actual data on disk. Because if I'm returning fields that are already included in the index, and the primary key is included in the index, remember, because it's at the end. It's used to look up the other tables. All it has to do is look through the index, and once it's finished with the index, it has all the information it needs. It doesn't have to go and look up more information. So if you're doing a select where the only fields you're getting are from the index and the primary key, you're sorted. The same if you could do a count on one of those fields. So you might occasionally have DBA saying, don't do count star, do count the primary key, because that's faster. And you're like, how? Why? That's the reason. That's one of the ones that always was a pet peeve for me. Like, why does that work? Well, there's the explanation why. So you're at work. You got your system running. Hopefully it's running and not on fire. How do you know what of your database tables need indexes? How do you know things need to be improved? How do you generally know that you need to improve something?
Usually customers complain, I guess.
Oh, that's perfect. Generally, your users are complaining about something. This is slow. And it's like, yeah, it's the database is slow. It's generally not the database that's slow, it's how it's been designed. The databases are very, very fast if we do the right thing with them. You might also have reports that take a very long time to run, and that also annoys you. Maybe you got a lot of resource hogging happening on your server while this is running. You can't do other things.
So query index.
Yeah. Oh, well, don't give it all away. Don't give it all away. We'll get to that. Generally, I'd say treat optimizing your databases, your queries, adding indexes as you'd optimize anything. You know, don't do it prematurely. Think about it. Think about how you build something before you build it, but don't over-optimize. Treat it as optimize when you see there's need to, because premature optimization is the root of all evil. So, well, the first thing you can do is you can explain your queries. So slap an explain on the beginning of your query, and MySQL will give you a nice little output like this. If it's a join query, if you've got a join query with multiple tables, it will have a different row for each table. Because the way MySQL works is it can use one index per table in a query. But that's also not really that clear. This is probably the most clear that MySQL ever tell you about the internals. This is the nicest interface they give you to look into it, and it's not really that useful. I mean, easy to understand to begin with. So here we have a select, and we're selecting from our user table on the name Bob. What this explain tells me is, well, we're doing a simple query type. That's fine. There are no possible keys I can use on this. There's no options. There is nothing I could pick from. In a pool of indexes, there is 0 I can pick from. And my final choice was, well, there was none. So there was none to pick from. And I had to go and get 1,582 rows from the database. And the filter tells me what percentage of them I actually returned to the user. That's an estimate. It's a very rough number. In this case, there was 1 record. So 1% or thereabouts of the records I had to go and fetch from disk and load into memory, I actually gave back to you as a result. And I had to use the where statement because there was no index, and I had to do a file sort. File sort is one of those things like table scan, bad word to see. So that is a bad query. Well, it's not that bad. Your table's not that big. It's still going to take a fraction of a second. But if you're expecting this number to grow, and I hope it is because it's your user table, and we want your business to grow, you're going to have to think about that because it's not going to scale with you. It probably needs some form of index. The next one, we do a query on the email address. Very importantly, we're only returning the ID and email, which means we should only have to use the index. So that's also a simple query. We do have an option. We have the email address. And since it's the only option, yeah, it's the one we used. Now be aware your index will be as big as the type field you're using. So email address, 256 characters, 254 characters. That's how big it's going to take up a fair amount of space because you have to restore that email address for each of the balance trees as opposed to a number, which is much smaller and more compact. But yeah, it makes sense on email address. You're probably going to be querying that one a lot. Hey, we got 1 row and we returned 100% of those rows, and we just had to use the index. We didn't have to go and look at the actual records on disk. because we just used the index. All the data was there. And here's another one. Select from the user where the ID is, well, that's a primary key lookup. Fantastic. Constant time, primary key, everyone's happy. That is probably the fastest query you can run on this table. Anyone have any questions about that? So if you do have a join, you will have a record for every single table. So this will return multiple records, each one for each table, which key it used. And that's very useful if you have very big queries of figuring out where the join is bad. Where you have a million rows this side, a million rows that side, and you're joining on, oh, no index. That generally means big table scans.
Do you have slides on that specific join topic? Or
No, I don't.
can I ask you a question then?
Yeah.
About it? If you have like a join with the multiple rows, do you have to multiply them to figure out how many need to be scanned? Let's say you have 100 on the one and 10 on the other. Is it then 1,000 combinations that it has to
No,
do?
so it does it sequentially. You'll do the first table.
I will repeat the question. So since there are no slides on the join, I asked the question, what if you do joins? Both tables will pop up in the explain result. You have to multiply the row values to figure out how many combinations it needs to compute.
No.
Or is it just adding them?
So Mysql dumps it down a lot. They do a query from one table, they get the results. They use that result to query the second table. So it's always going to be a linear set of queries. So it's never going to be like, I got 10,000 potential results and I join it to 10,000, unless there's because it's always going to be on the on statements, and unless you're doing a left join versus a normal, it gets complicated very quickly. Generally, the explain is it will give you some hints at what's going horribly wrong, but then I think we start talking about having an entire session just on optimizing your queries, and we do not have time for that. But if you have big queries, my general approach is don't. Right, you can actually force an index. Generally, as I said before, do not do this because the MySQL engine is much better at guessing this than you are. But there are some valid use cases for this. So you can use an index. That's fine. It just says, look, please use this or one of these indexes. You can force an index and say, look, I really want you to use this index. And you can also ignore an index. These two are quite useful if you want to see, hey, I have an index. I'm not sure if it's particularly useful. What happens if I drop it? But before I drop it, let's check what my query would look like. How would it perform? So you can slap an explain at the beginning and do a force index and see how it would perform. Or just run it and see what happens. I have done interesting things with the table with something in the region of 500 million records, where I did drop an index and then regretted it afterwards. So it's always good to test these things before you drop an index, lock a table for a couple of hours, and then realize you actually needed that back. Yeah, there you go. There's the logging. All right. You can also turn on logging. MySQL comes with a lot of nice built-in logging, and one of them is, well, there is a bunch of them. So you can turn on slow query logging. So you can say, hey, if a query takes a long time to run, please log it for me, just so I can come back and actually see it and decide, oh, I need to do something about that. And what a long query time is considered, which by default is 10 seconds. If a query takes a little more than 10 seconds, it's probably slow. Maybe you want to make sure any situation where a query has to look at a lot of columns. So if anything under 100 rows, I don't care about. But as soon as they do more than that, that helps you limit what records you get in your logs. Because there's a, oh yes, log queries not using indexes. That's very useful. That tells you if you're doing full table scans. And then you can specify where you want it all logged out. And there's nice tools now that you can take that and stream it into all sorts of interfaces and have nice graphical views of what's going horribly wrong with your system. Your DBA is, hopefully, if you have a DBA, is already doing this and is probably already knocked on your door to fix stuff. But if not, you can turn it on yourself. There's also something called the Performance Schema. You will have to turn this on for your database if it's not turned on already. You'll need to actually set it up in your configuration file. So depending on your distro, you want to add this to your configuration and restart your server and make sure that it is actually turned on. The Performance Schema is really, really cool. but whoever designed the naming scheme for it is a sociopath. I'll show just now. Be aware that these tables in the performance schema are all memory ones, which means they only retain memory since your last restart of your server. So it tells you what's happened to your server since it restarted, which is kind of useful because it means it's constantly flushed clean data, and you can do really, really cool things like you can see down to the picosecond how different queries are performing if you are that kind of person. So, as I said, designed by a sociopath. You can there's a couple of tables here, and the one I think is really, really useful is the event statement summary by digest, which is a mouthful, but it's pretty much the summary of my statements by generalizing the queries. So if I run a query where I look for an email for that person and an email for that person, it's technically the same query because the only thing that's changed was which email address I look for. So those are both the same query, and if they perform well or not, I kind of stack the results on top. So this query here, select the digest text. You can see here they've got a placeholder for the name and the sum select scan. And sum select scan means I had to scan the table. That's a table scan. And so what I've asked here is please find all the situations where we had to do a full table scan, ordered by the worst offenders. So this table, since the server last restarted, there was 700 queries on it that had to do a full table scan. And so this kind of gives you an idea of not only where you have full table scans, but also where the most hits come from. And there's other fields you can include, like how long it took to return the results, aggregated, and how many records you have to look at, and so forth. So this is very useful for very quickly looking at your system and seeing what are the big targets, which are the ones that if I can fix this will give me a big performance boost, as opposed to the long tail of, yeah, that query takes an hour to run, but we run it once a month, and that's not a big problem. You can also query to see what the ratio is between the number of rows we had to look at and the number we actually returned. That's not always the case. We could have situations where we're using an index, but maybe the index is not very good. Maybe we got an index on, is this user still active? Yes, no. Well, yeah, if that's the key, the index it ends up using, and I have 10,000 active users and 200 inactive users, I'm still going to have 10,000 I have to then filter through for the other things I care about. So that's also a really nice query to run just to see what are the big targets to hit. Yes?
The schema between the square brackets, that's just the placeholder, right?
That's the placeholder for your schema name.
Okay.
All right. The question was the little square bracket schema here was just my placeholder, because if you don't put that in, it's going to give you the ones for all the internal databases as well, like the Mysql database or the information schema, and you don't really care about those. That's MySQL's problem, Oracle's problem to fix. I also wouldn't recommend trying to fix that. Cool. Oh, one thing we do need to kind of take a quick step to the side and talk about is cardinality. Who's familiar with cardinality? Yeah, okay. All right. So, cardinality. What is cardinality? Cardinality is uniqueness. Your email address is fairly unique. I'm pretty sure no one else has your email address. If they do, I'm sorry, you're probably already stealing all your money. So if I have a table and it contains an email address, I can be fairly certain if I have an index on that email address, and I search for an email address, I should get, hopefully, one record. On the other end of the scale, we have things with a very low cardinality, and those are like Boolean. A Boolean is either true or false. That's the only two options it could be, or maybe a small subset of types. Like this is an active user, or an annoying user, or a deceased user because they were annoying. There's only 3 combinations there, so if I build an index just on that field, it's not going to give me, it's not going to filter my results if I care about other stuff as well. So understanding the cardinality is very useful in deciding what other things you want to build indexes on. As an example, that 500 million records table I'm talking about, which contained very sensitive financial information that had large financial repercussions on booking.com, which I love to play with and drop things and add things, and contains a type of transaction. And it has 500 million records as of the last time I was actually working on it, and I've been away for a couple of years, so I imagine a couple 100 million more. but 90% of the records have one type, and 10% have a different type. Now, if I'm querying and I want to see the different type, an index is great because that really removes 90% of the records that I can filter on, and 500 million records, that's a lot of records I got rid of. But if I want to select on the other 90%, it's useless. So sometimes it might be useful if the cardinality is imbalanced to have an index on it, but you also need to be aware that having an index on it doesn't just make it faster. You can actually see what the cardinality of your schema is. The cardinality of your indexes. So there's a statistics table in information schema, and it contains a record of all your indexes. And so you can, if you create an index for a particular column, it actually stores the cardinality next to the column, next to tables, the table schema. Table name. I think that should be table name, not table schema. So that actually, you can pull that straight out of the database, as opposed to doing a count on divided by count distinct divided by count, which, depending on your 500 million records, is not a good query to run at any point. I will belabor the point that I have had to deal with really large tables before, and these small things matter a lot in them. Yeah, so that's very useful. That table contains all the information about your indexes. So if you ever want to know about what your indexes are and how they're configured and what their cardinality is and their order and all that stuff, that's the table to go query. But you do have actually a couple of options in creating indexes that actually can help with that, especially if you have a very low cardinality. Low cardinality, yes, low cardinality is when you have very few options. High cardinality, very distinct. So you can combine columns. You can say, hey, I want to create an index, and I want it on this column and that column, because remember, MySQL can only use one index per table. And if you have 3 or 4 different columns that are something you commonly query on, and one column alone doesn't create enough uniqueness, and you end up doing a lot of rows returned versus ones you actually have to go and look at, you can create a combined index like that, which is cool. Yes?
Is there a point, if you have like an index on A and B, to also make a separate index on only A, if there are all circumstances where you only look at A?
No. That actually will come up in a bit. Yeah. Oh, you got a question, right? Question for the. Oh, repeat the question. Sorry. So the question was, is there a situation where we might want to just create a index on column A, as well as a one on column A and column B? That is something that will come a bit along in a bit, and it's called a redundant index, and it will never be used. Whether you want to create an index on column B is a different matter, because when you create an index like this, if you write a query and you go where column A equals X and column B equals Y, it'll use that index. If you write a query of column A equals X, but don't do anything with column B, it'll still use that index, because starting at the top of that tree, it is all the records for A, and once you've gone through all of them, then column B takes over. But if you write a query where it's just column B equals something, it won't use that index because it needs to have column A first to traverse the first part of the balance tree. So that's also important to know. Is if you're going to make a multi-column index, you need to you always need to use it in the order you specified the columns. You can create a truncated column if you have a field that you don't necessarily need to store the entire value, because the uniqueness of the field is quite apparent within the first few characters, for instance. You can actually truncate it. That will save you space, especially on really large tables. So for instance, email addresses. Email addresses get quite generic at the end, at Hotmail, if anyone still has those, at Gmail, at Outlook, at Live, at Microsoft. But the beginning part tends to be the most unique part for most email addresses, unless it's Bob. So you might just say, I want the first 12 characters, and after that, I'll sort it out. But it does mean that if you do use that, you don't get the advantage of just being able to use the index to return results, because it won't actually contain the entire result, just a truncated portion of it. So it'll still have to go and look at the actual records on disk to get what that field was. Yeah, and always be aware of your primary key, because your primary key is going to be post-pended to all of your indexes. So if your primary key is a varchar 255, all of your indexes will have to have that added on the end, which makes your indexes quite big. Once again, it doesn't matter for small tables, but when you start getting to 500 million, and they keep going on about it. But yes, that has a massive impact. As an example, that 500 million record table has more space used for indexes than it does for actual records. Yes. Throw the microphone at him this time. Throw it.
I have a question regarding what you just said about the primary key being appended. If it's a varchar of like 255 characters, does that amount of storage or amount of data
Always get reserved in the index table, or
yes,
is it?
So that node will have all of those email addresses recorded in them. So that will also affect how big, how
With
many
space
records your
for
node can have, which affects
255.
your balance tree. So yeah, there's an actual size of how big each of those nodes can be. And if you pack it with a whole bunch of strings, you can pack fewer nodes, which means you have to have a bigger depth on your balance tree. And there's maths, there's logs and other scary math stuff.
Okay.
I realize we've got 8 minutes left, so I'm going to try and be a little bit faster.
It's a community session, so we're
Oh,
not
fantastic.
really
No one cares.
really looking at the clock, and we're
I'm looking at those snacks. So, so here's a good question. Which index is going to be used? And I've given the answer away already.
First one.
Yes, first one. Email name, because email is here. This one won't be used because I need the name first as part of the query statements as well. So you might see someone write that and you go, what the hell are they doing? That's wasted space. No, there's actual potential valid reasons where maybe, okay, this is a bad one. If you're giving both, then it doesn't matter which way around. But you might have situations where you have multiple indexes using common columns that have been indexed in other ones in different orders. Yes.
Free question, because nothing will be done.
Oh, but why is that?
Syntax error, I think.
So no index will be used. Select alt table.
From. Ah, okay. Yes, yes. Right.
Sorry.
Hoisted on my own petard. You're having too much fun in the session. All right, so this was our original table. Users, we had the varchar, no primary key, and so forth. So what we could do is something a bit like that. We're going to add an explicit primary key, so we don't have massive. Even if we're using the email unique thing as a primary key, that's still a big primary key because it's a big text field. And I still didn't change it to 4, so don't look. And then I like being explicit at the bottom, but this is a personal preference. You can still leave unique over there. But I think it's probably important for us to have an index on the name. Maybe not the whole name, just the first 16 characters. I think that's unique enough, especially since 255 is a lot of characters to potentially reserve. But you're asking about index reservation. I'm not actually sure if index will use all 255 for every record, or whether it will varchar, it will kind of one record for the size and yeah. And then probably also one on the country and province, because if you're going to query on the province, you probably already know which country you care about. And so that's probably a good one. And we don't need the whole province either, because there's not that many to pick from. So how are the indexes actually selected? I mean, we talked a little bit about choosing which index, but there is actual rules that MySQL uses to picking this index, and we've kind of talked a bit about them already. And I apologize for the wall of text on this one. But yeah, first thing is it kind of looks at what did you hint or force. You know, use the index look. And then do you have an index that actually matches the whole where statement? Do you have an index that contains all the columns that you have in a where statement? If so, that's what it uses. And then if not, then it has to be a bit smarter, and it has to look at a situation where part of the where statement, there's an index that matches part of the where statement. And then it needs to pick which of those is the best one, which is when it goes and looks at cardinality to decide which columns have the best cardinality. Or the smallest row result, which is cardinality plus extra stuff in the background. So that in a nutshell is how it goes and determines this. So in some circumstances, when you have very balanced cardinality, it might make sense to try and force or hint that it should use this index or not. But generally avoid this. You know, have a DBA hold your hand if you're going to do this, because generally you want some reassurance that you're not going to explode anything. Interesting enough, the where statement can only use one index. Your order by and group by can also use an index, and it doesn't have to be the same index. This is also quite useful because if you have a very big result, and then you want to order that result, and you have to go through it manually and sort it, that's really, really slow, especially if you're returning a couple million records. So it can actually use that index, because that index has that whole nice range function on it. So you can find the IDs within a certain range and use that as your order function. So it can do that. And group by can use the very first column you specified to make the grouping faster. So those are also things to consider. Not sure how it doesn't provide much context in explain about how it chose that, but it does do that in the background. So if you're seeing a lot of file sorts on very big data sets and it's very slow, you could tinker with this. Same thing. Ask a friendly DBA if there's one available. So we think we know how it selects indexes. We think we know how to build good ones, and we've built some, and now we need to see, is it actually working? How do we know if the indexes we actually built to fix the problem worked? No. Well, same thing as we used for the identification process. Has the user stopped moaning? Are my reports running faster? That's generally the great way to measure that. There are a couple of other cool things you can use. For instance, there is a table explicitly called schema redundant indexes, and it says these indexes you've created, I am never going to use ever, because this one is always better. You can run that, and it'll tell you exactly which ones, and you can drop those indexes without any worry. I mean, yes, there is some worry. You need to worry about locking your table for too long if it's a really big table, but you shouldn't have. You can drop them. You save performance, because obviously with indexes, each time you insert a record, you need to update the index. Each time you delete a record, you need to update the index, and the index takes disk space, so there's a performance space and performance time cost of an index. And going back to the performance schema, there's another table very, very clearly labeled as table IO weight summary by index usage, which pretty much is a great way of finding out if your index ever gets used since you restarted your server. Again, since you restarted your server, very important to know. And that's a quick query, and you can see they don't even use the same naming schemes between some of these. But yeah, that will tell you exactly which table and which index name has not been used since your database restarted. Any questions about that? Performance schema is really cool, but explaining the tables are utterly useless because they are opaque. The documentation is non-existent. So generally what I do is I find smarter people online and read about what they say about it. Do you have a question? You look like you wanted to ask a question.
I was just wondering, the engine of the performance scheme, is it?
It's memory. Memory. So the performance schema, most of the tables in it are memory tables. Actually, it's a bit weirder than that. So if you ever go to your information schema and you go describe table, it will show you a very standard table. Go show create table, and it's just crazy. It's views conjoined with in-memory tables with opaque names, even more opaque than that. Very cool, but right. So this is the end of talking about indexes. I know you're all way smarter about indexes now, and you're going to go back to your work and you're going to create question.
Yes, I have a question from the audience. Can MySQL use multiple indexes for a single query for a single table?
It can't use more than one index per where for the where statements. So selecting the data out of the table, it can use one index.
Mm-hmm.
Sorting the data, it can use another index, and grouping, it can use another index. But for selecting the data out, which is really normally the most performant expensive, one index only.
Okay. Well, I will ask if that would satisfy the question.
For InnoDB database engine.
Okay.
There are other database engines out there. I cannot attest to understanding or knowing anything about them. So now, I think, has everyone survived? Is everyone okay to go on for a bit longer? All right, let's talk about some cool tools. Who here knows about some cool tools about MySQL?
MySQL Slap.
MySQL Slap. That sounds really cool. What does it do?
Okay, Mysql Slab is what I call the performance benchmark for MySQL databases. It allows me to benchmark my queries. It allows me to do performance testing.
So like Apache AB.
Yeah,
your
like
database.
Apache AB, but then for MySQL databases.
Yeah, Booking, we call that our front website. That's but that's actually really cool. So MySQL Slab, all one word, or
MySQL Slab, yeah.
all right. So anyone who's watching online, feel free to Google that. That sounds pretty cool, actually. And
That was not part of your toolset.
no, it wasn't. No.
Okay.
Look, there's a lot of tools out there, and I didn't even heard about MySQL Slab. So that's something for me to take home.
Yeah.
So this one actually is one I hope almost everyone here knows about. Yeah. So this tool is actually pretty cool. I mean, it is made by, it was made by Sun, and then Oracle bought it, and it seems to get updates occasionally, so that's good. It's actually really cool because it combines an administrative interface for watching your tables with the query browser, which is also quite nice to use, especially if you're not a huge fan of the command line interface, as well as a really cool tool for designing tables in that view, and then actually creating them in your database, or taking an existing database and reverse engineering it into a diagram, which is quite nice if you want to get a quick overview of how everything is connected in a database.
Yeah, we had the schemas created in Workbench, and because it was a very huge data structure, we had it plastered on the wall. And the CEO was always, when he was touring around, he was always explaining, and this is our data set. And he was always referring to the schemas that we have plastered on the wall, because he was so proud about seeing it visualized like that.
Oh, and it's got nice little coloring things as well to kind of group that stuff together. So yeah, this is a really nice tool. I use this for my personal projects. I have not tried to load 250,000 tables into it yet, but we'll see. I suspect it will run out of memory before it runs out of tables to load. There's MySQL Dump. Now, hands up here who has a backup solution for their databases. Yeah. When do you need a backup? Yeah, you need a backup before everything blows up. If you're dealing with something, especially if it's a small shop or it's a personal project, or you have someone's system who kind of quasi providing support, but it's not really your job, and you need a backup solution for them, that is a great way to set one up very quickly. There are a lot of other cooler tools and more professional tools, but if literally what you need is something to prevent your uncle and aunt's web shop from blowing up and never being recoverable, that's a very quick way to set up something to back it up every day. And you probably want to pipe that backup off to an email address or to file storage, so it's not on the same machine as the database. So if that blows up, it's still safe. But that's a very quick and dirty way to get something set up right now. I put this up purely because a lot of people don't think about it until it's too late.
Okay, I have a question about the Mysql dump command on your screen right now. Let's say you have a big database. How much will all of the data be dumped in memory and piped to data before it gets written to the file, or is it
streams
flashed?
it? Because yes, there can be a lot of data. It streams it out. Although because I've got a pipe, it will, and it's tarring. I'm not sure if tar will wait for the entire output before it starts. It probably waits, or will it do it streaming? Oh, fantastic! It'll do it streaming. Thing is, because what it's dumping out is literally the order of SQL queries to recreate the data, and a lot of it's duplicate. It compresses very nicely. So the output from here will be very big, but when you zip it up, it'll significantly decrease the size. Yeah, so always just put that in.
Yeah, I just want to say the only issue with this, of course, especially if you want to do a proper dump, you have to use like --opt or something, which will lock basically everything. and then
I'm hoping if it's a small enough where that's the solution to set up, you're not
yeah,
getting the
for
kind
a
of
small
traffic
shop,
to your
this
database.
will be fine. Yeah, definitely.
And also because the people listening in for my talk tend to be a mix of people across various experiences. Yes.
Yeah. One other way is that you can also have the Mysql dump stream to Zcat. So it actually comes out compressed, and then you just have to write it compressed in a file.
Okay.
So now
All right.
you're.
I think we're micromanaging my code. But yes, I know, and it could be better. It could definitely be better.
I'm just saying.
All right. Then we talked a lot today about all these things you should be aware of when building your tables. But if you don't necessarily want to remember all these things, or not sure how to do it, or want something to do it for you, this is my tool. This is actually a rewrite of something I had to build at Booking to solve the numerous problems we have at Booking. And what it does is it does a static analysis on your database, and will tell you what you did wrong. In a nice way. In a nice way. In fact, I think I've got it. Haha, there we go. So you can run it on your, where's my mouse? You can run it on your database, and it will give you a very clear list of things you are doing wrong. So okay, there we go. Here's a good example. Select start from user where substring email address. What that means is I'm running a function that modifies the email address. Now, if I modify the email address before I look something up in that balance tree, I'm not going to be able to use the balance tree at all because I've had to get the result, modify it, and then check the result. So what you probably want to do is write your query in a different way, because that means you're not going to be able to use that index, which means you're going to have to do a full table scan. Or you have situations where you have a very high cardinality index with text columns. You should probably consider using a prefix, because the uniqueness of these columns are quite high, and it's a very big string. You're going to save a lot of space if you squish it. Although that's not a big issue. You can tell it just to give you the big ones, like that table should have a primary key, or you're running MySQL that without SQL require primary key. Fix it. I know, a bunch of other ones. Yeah, table with an insane primary key. There you go. I like that one. That one's you've got a string as a primary key. That's a bad idea. Your index is going to be huge. I've lost my presentation. Oh no, I have lost my presentation. No, the keys are too small. Aha, back again. All right, so Tadful, that was, yeah, trying to tame 250,000, 290,000 MySQL tables. You generally come up with an automated solution, and this is a lot of the stuff learned from that automated solution. Other ones being, who owns this table? Why is there no owner for this table? I'm going to assign this owner to some table. I'm going to look through all the code automatically to find out who's writing this table, find the Git authors, make sure they're still alive and working for the company, and then hold them down and beat them until they agree to accept the ownership of that table. Right. And then this is something that's been very useful at Booking, because Booking is fairly big scale-wise. And we have situations where we have really large tables and we want to change the tables. And if you've ever tried to change a large table, it tends to lock it. And when you are getting 1 million hits on your website a second, locking your table is not really an option, especially if it's really big. So we use online schema change tools, and they're actually quite cool. What they do is they take your table and they create a new table of how you want it, and then they start copying the data from your old table to the new table. So you add a new column or you add an index or something. So it'll create that table and it'll copy the existing data over and over and over and keep doing it until they are both in sync, or as close to being in sync as possible. And then, in a quick atomic action, it swaps the tables around and puts the new one into production and takes the old one out. And it works, which is quite impressive. So that's how you go, oh shit, I dropped that index, I'm going to have to re-add it, and I start running this process, and it takes a month. So be very careful about dropping indexes. Is I hope the takeaway from this talk. Yeah, there's a couple you can actually use. There's Bacona, which do a lot of cool stuff with MySQL, and they write a lot of very advanced things with mathematical formulas about how it works. Facebook has built one, if you want to, you know. And GitHub has one called Ghost. So online schema change, OSCs. If you're at that scale, it is very useful to invest in a tool like this. Your DBAs probably will thank you. So what did I cowardly skip from this presentation? Yeah, well, lots of things. Didn't talk much about primary key design operations, because there are actually some very interesting, you can read the documentation, types of primary keys you can create, and I'm not going to talk about them. Because they mess up half the things I talk about. Because every single thing I talked about has an asterisk next to it when you deal with different types of primary keys. I didn't talk about foreign keys, because that's something a lot of people do use or other people religiously don't use. There's issues there, especially when you start dealing with triggers. MySQL has a bug report that's old enough to drink in the US, where it's a combination of triggers and foreign key with cascade delete issue. So I'm not touching foreign keys. We don't use foreign keys at bookings. We do all the logic in code. Yes, that's a big statement to make. I didn't talk anything about date times or timestamps or time zones or daylight savings, because that stuff is just, there'd be dragons. I didn't talk much about scaling beyond complaining about my table sizes. Or about things like size estimation versus, you know, data types and how we can optimize your data types to pack the most data in smaller space as possible. Also because I have a personal vendetta against people who add bitmask fields to my database tables, and going, what does this mean? What does this particular bitmask value mean, you bastard? And then they say it's in the code, and they go, yeah, no, it's not. And I didn't dig much into the internal tables and schemas that MySQL has. So there's the MySQL schema, the performance schema, the information schema. We touched on it briefly, but there's a lot there. And if you're bored, switch to them, do a couple of describes, select from them, see what happens. I will hang around, because we're going to talk afterwards. So if anyone wants to pick my brain about something or talk about UUIDs, we can do that. Right. Any last questions? Fantastic. That is my Twitter handle. I don't post or retweet or say anything meaningful, so don't follow it. But I will post the, and you can share it, the links to the slides afterwards. So you thankfully don't have to remember all those queries I wrote. You'll remember the queries I wrote, right?
Question from the online audience. Probably opening a can of worms here, but did I hear correctly that you said you didn't use foreign keys? If so, could you briefly elaborate on why?
Okay, that's a good question. I don't know if I want to elaborate on why. Okay, so Booking has an interesting setup where we have a lot of schemas, and those schemas don't live on the same databases. So instantly, foreign keys don't work across schemas, and it doesn't work across databases. So that's a non-starter. Also, 290,000 tables. If I created something that did a cascade and I deleted a record, let's say a hotel, and watched it ripple out into the Booking ecosystem, it would burn cities to the ground. So a lot of how German. Yeah, so he's prolific and he tells you strange things about databases.
It's back.
Oh, fantastic! I'm literally doing a talk where I'm just browsing someone's blog right now. This is great. I sound weird. I didn't want that. No, that doesn't work. Never mind. Yep. So I do recommend, if this was at all interesting to you, do not follow me. I don't know things. I just repeat things other people tell me. These people, very interesting. Follow them. And that's my talk. Do we still have a question or any questions unanswered? Fantastic. I'm starving.
People are typing.
The suspense is killing me.
Yeah, somewhere, I think with the network glitch, the screen was not shared. So you're only on the camera with... Fortunately, we had everything on the back.
You're getting a thanks for the insight on the non-usage of foreign keys.
Yeah. There's other reasons and probably more complicated reasons why that involve internal workings of MySQL and performance. I'm going to go. That's all grand. Ask him.
Okay.
There we go. All right.
Well, thank you, Thomas. Again. So, we're a little bit over time, but that's okay. We're a community, and at this point, yeah, we're just trying things out and learning as we go, with all the video and sound issues that we could potentially have. What we're going to propose is that we take a 15-minute break, especially for the people online. They will probably need to have some time to recover after the mind-blowing speech of Thomas. So, and Thomas is very hungry. Everyone here can hear the rumble in his tummy.
That was mine, actually.
So, 15-minute break. We're back at 20:35. All right. I will leave the mic on so people can actually participate a little bit with the discussions here.
Yeah, I figured.
For a bunch of reasons, one not chronological, but that's being solved by UIT version 6 or 7. That's on the draft.
What did it 7?
6, 7, and 8 actually on draft. There's a RFC, but they solved the chronological portion by having a timestamp factor on the beginning as opposed to the end. So at the moment the UIT puts the timestamp portion on the end.
yeah, it's all still in the same notation, but they use that the first part now, which is one of the time-based, and the second part randomized or X-based.
Het is nog een keer de opvolger van iets. En je hebt wel
Yeah, so there's still an distributed manner between its generators, so they have occasionally time limits. So when you insert one of those, what tends to happen is, because if also incremental IDs are sequential, or UIDs are sequential, when you add them to indexes and hierarchies, they just add to the balance tree at the bottom. And those portions of the balance tree stay in memory. Because they're hot. So yes, with current UIDs, they can be inserted all over the place and have to be inserted because they run like targets. And so you end up with sort of same recent data to hot. Because you can only hold so much memory. Most copies. So you recent stuff, stuff that's maybe a couple of hours old, will no longer be hot. But it's data you want to create often, and also you generally want to see what happened in the last hour. As you select by timestamp. At scale, so what someone did before, so project UI got task, you rearrange up the timestamps of the data and then assemble it again. So you generate your UID, you rotate it around, the new UID is a draft, you actually solve it.
It's a bit outdated.
We had it produced pre-corona. Yeah, we are. Oh wow. That being said, they're all in draft, which means no one has done a full mobile. A lot of people have built libraries.
already implemented?
Probably. But they're not finalized draft. Which means they could change. So this is 2001. New time-based UID format. So yes, use UIDs. Use this one, but this one's not a finalized draft, so maybe don't. You have a UID that have a current also, so UID. No, you just have a unique constraint for your UID because you should be unique.
Query mensen deze kant moeten sturen dan bij mij.
So when anyone gets the chronologically, you get a view based on
Iedereen. Dat is zo, ja. Je kunt niet diamanten vinden. Dus ja,
technically, you can actually use a hash index because you're always going to look for the UID, you're never going to do a range because range doesn't make sense.
Nee, dat is
Longest term changes that you can be able to manage with line data sets change. But you also need to be careful to make sure your ORM layer doesn't end up with a ton of logic in it, because that's a pain to update later. Also, I like the separation of the write and read design controls as well, which does help make it a little bit nicer to separate how the data gets updated versus how you present your data. But I'm not religious about it. What works for our teams one time, it's a problem. It's at scale.
Yeah. Then you
Yeah, and then I spend a fair amount of time. So whenever you create a new table, also booking, you go through a review process. You literally go through a statement and you pass it, goes through it, and goes, no, don't do that, don't do that, don't do that, stop doing that. Why are you doing that? And then they make the changes. Submits it for approval. Someone approves it. It gets created in the database automatically, or altered, or automatically altered using LC. It's very big. But then we also know exactly who requested it, which team they belong to at that point in time, so we can assign ownership to that team and say, hey, you've got a new table to belong to. And if I have any questions about that table, like, hey, this table, I have no idea what it contains, I don't know what it's classified for usage, I don't know what the data retention policies are, and I don't know. No. Yeah. Removing other people's data is a great way to make friends. No, because if I delete someone's data, they're going to be very happy. But I can say, hey, we have a data catalog. You need to provide explanation what these fields are, what you're trying to store, how long was it for, what can we use it for. Because if someone comes along and goes, oh, that's nice data, shame if I used it for something important, booking, and there's an entire reporting chain that depends on this data being correct and up to date. And having these guarantees, I'm going to tell them, sure, go for it, unless you tell me otherwise, unless the owner of the data tells me otherwise. So yes, we're going to make sure that they can't come back to me unless you go, we want to change the table or move it to somewhere else or get rid of it, but they tell me that they're using it for our reporting to stock exchange, CEO's report, Suarez board meetings. He's helped me get all of my data and go classify and say they couldn't use it, so they used it. Which also was a lot of problems. A lot of people just reach into people's operational data and just stuff out.
En uiteindelijk collega's zijn bedoelde met advanced stuff like
we have access control, so we know someone has access to read or write, and the has to be granted. And we do log queries, so we can just look back log stash style to what have queries we've run in the last X number of months on these particular tables or this database containing these phrases. That's 290,000 tables with a lot of queries. That's a lot of stuff to look through. So we try and do this the same way of going. No one's classified this, but I know who belongs to, so I'll send them a little message and say, hey, and I won't do manual updates. 290,000 tables are automated, so they get annoyed once a week to say, go for this data.
Yeah, that's a big thing.
And that's just a massive.
Makes me feel better about that.
Well, the thing is, once you get past a certain scale, I mean, you generally, I worked with different sized teams and different sized over up to a certain size, everyone knows what the data is, they have a clear idea, they know roughly that area almost. So they have all the shop past those. 2,500 developers. No one's going to keep asking you what this is and what is it. I have no idea what this bit mask is and what it's supposed to do. Me. And apparently it's in the code somewhere, but I don't know where in the code. There's no link between the data and the code. So you have to start figuring out ways to get that information shared. Otherwise, you end up with tables that people create dependencies on, and we found out a year later that half the data. Feel this is even less effective than address. No one, the person who wrote the code is the company, and the team, there's no team maintaining it, no one wants to claim it, so no one wants to fix it. No one wants to spend any resources on it, because technically it's not theirs to worry about, so yeah, it becomes this thing of going on to figure out who's producing it, who's consuming it, and making their problem. And that's a full-time job. That's pretty much nice.
Hey, right now, you had a break or you were away for a couple of years, or what did you say?
Oh no, I've worked at different size companies all the time. So Booking is the current one, and bigger and bigger. It's a whole new level because you also have this version in terms of doing GDPR, applying for all the things. Where's your PII? All sorts of interesting PII systems to make sure.
Ignore the backups.
No, backups too. We got a solution. Oh yeah, so we don't have any PII backups. We have a complete separate system for managing PII. So you don't, in your database, you don't store PII. What you do is you store a key, and you ask that service for that key, and it'll give you the value. There's no way to turn the key into the value without that service. You can't write for every service. And then that service is replicated in multiple places, so that if one fails, we've got backups, and each of those are in a very secure, neutral place. And if someone says GDPR request to forget, we remove the records from the system. So we still have the keys. We don't break all the data. But you can't resolve back the personal identifiable information.
Data so maybe just store like a hash prefix so you can actually.
No, not even the hash. No.
What if it's like a list of a blacklist of bad actors that are bad for.
Okay, so in this case, it doesn't matter if they ask for a GDPR request. We have a legitimate reason not to. Fraudulent or something like that. We would say, hey, we need this to work because and when you ask for a GDPR request to be forgotten, we need your email address to be on record saying you asked to be forgotten, so we don't bring the rest. We have left as you asked to be forgotten. And that's it. Yeah,
dat kunnen ze meestal niet zeggen.
it means that all of our business, if you're a developer, create the database correctly, there's no problem.
Nee,
You have to literally write code that goes and says, hey, I've got this key, give me the PII, and all of the project exactly which service requested it, and it's running at the time, and
standaardisering.
the full life cycle.
Heel mooi.
To like search for
Meerdere people.
Yes, you can't do a search for all the people named Bob, but then I will ask you, what reason do you have to search for people named Bob?
How many users?
How many users
You,
do we
you said over 500 gigabytes data, right?
Oh.
But about how many users in there?
How many users, how many MySQL users connected to the
Ah,
database?
no,
How many structural?
okay,
Now you're
members.
me responsible.
Booking dot com members.
Well, you can actually book stuff with us without becoming a member. You don't need to give it, we'll create an account, you can just book it with us. But it's a couple million reservations a day. So it's a lot. Although it's high season now and you've just come out of COVID.
Ja.
But yeah,
We zijn een kijker vergeten, maar we
we
moeten
have a nice little
live
countdown chart that says what number do we want to hit today, what do we estimate, and then we go to the pub and we put up on a big screen.
Het is wel gelukt.
Post
En dan
tickets
zo,
to break
ja,
the
maar
record.
cool. Ik zie
How to
wel.
monitor
Ik heb
the
15
data?
deep dive.
How to monitor it?
Well, I mean, if we're monitoring how many reservations we get for a day, for a 24-hour period, and we think we're going to get to the record, we'll put out and say, how many reservations do we have today, and still no one cancelled. How many were created today and haven't been cancelled yet? Just put that on the graph, and we work out from
Buiten een
because
bij
we're,
ons
let's say, 10
Ik
second,
naar mij
20
begonnen
second.
in dat 20 jaar.
How close are we to, if we project it, or we hit our record based on historic trends, because obviously, depending on the time of day, we have business in different parts of the world. And we're bigger in some parts of the world, not so big in others.
2 weken
Are
later.
we projected to hit the record, or are we going to miss it?
Ontslagen.
And then we'll go to the pub, we start having drinks to see if we're going to make it. If we make it, we have beer. And if we don't make it, we have beer to commit. And in fact, the pub outside our office was reclassified as one of our
Yeah.
quite listed, so we can put a screen in there from the network, so we can put up the big countdown. Yeah,
Nee, hè,
Used to-
dat
it has changed a lot more corporate.
Yeah, and there was also like some downsides.
En
Yeah, so during COVID, they laid off
nieuwe
a bunch of our customer support because we didn't have business for them.
Is het niet eigenlijk?
Yeah, that, and then more recently, the company decided to sell our customer support agents and the offices to a third party who is a general contact support center. Yes, they resell a lot of
Oké, maar op zich in het hier wel oké.
Unhappy feelings amongst everyone about that.
Except for the boss. Nee, ik bedoel mijn annotatie.
Very happy with it.
Allee, ik wil gewoon even weten dat ik geen kan.
So they're not firing. Because each of the contact centers will take into account and booking they'll send the words of booking and booking would pay them plus 10% as profit and that's the tax on in the area. So that's how they manage the tax part. So there's the one Barcelona, one Berlin, Frankfurt, a couple in the US, one in Cambridge, and why they manage it so because obviously all the business gets done through Netherlands. So all the money that gets paid in the Netherlands, but then all the places that have booking companies and like tax because you're not making any profit because it's usually more expensive. So treating this company as really simple.
Dus de regel dat eerst als investeren passeren.
But then they can sell the whole company to another company, including all the employees. It's just an acquisition.
Alles staat
We're well, that's until they've been trying to outsource it to the web. No, well, they're trying to go cloud now. They're trying to go AWS. They didn't take into account.
Nee, wacht. Ik kan dat lezen en denk van, eerlijk, kijk een Jira, zie je al dat dat 5 uur geleden opgelost is. Maar gewoon via Slack. En heb je daar een oplossing voor? Is
And that Jenny works to
Jira,
two sides.
zeker,
We're on the other side of the scale.
soms dat dingetjes, dat denk ik moeite.
So the thing is, and we also need to be able to have a service bus which put in the cloud. Because you have servers. You can use them to full data centers. You can use them to full capacity because we pay. If we see that it's really growth of new service is exponential, then we go, okay, guys, start looking at what you guys are actually putting on budget into it. That's it. But even then, you have capacity. Cost us more. But I think the capital expenditure on servers, expenses on web, well, that's much more attractive than tax deductions as opposed to buying servers and application.
Ja.
I hear no data centers are I don't think we because of COVID, we had to grow a lot more. So we've been able to pick up our hardware at a slower pace. So we had some reserve. And we did budgeting each year. You keep everything in memory, so your business.
Maar dat was die een andere helemaal niet oplossen.
Ah ja, dus ik zal deze background even boeken met illustratie aanhoren van.
Ja,
Dat is wel dubbele prijs dan.
Maar dat was zo de klant die had gewonnen, die niet gewonnen was. Een mooi knowledge gehaald.
Yeah.
Okay.
Zodat je
Screen is now working.
very nice.
Now we need to connect the wires so we
Very
can
awkward
also
moment.
have the screen on.
Yeah, so that they can see because
Yeah.
with Thomas, they luckily he posted the slides,
Yeah.
so they were able to follow on the slides. But it would be easier to follow on the online.
What the first thing?
It's always something.
Will it work?
Okay.
Very good. Will it work?
Ah, nee, dat
Now it works. I mean, we now have screen.
Oh, okay.
So,
For the
Okay, so yeah.
yeah, I mean, except for one little glitch, the sound was working.
Okay.
So,
now we still need to
Is
situated
Well,
or it's just
I need to wire him up.
Oh, okay.
So I need to wire him up, and then secondly, I need to have him connect
Are you
to
like
the
the
stream,
couple developers
so he can share his screen.
the Netherlands, so they
Right.
can like use it as a tax haven,
Then
or
it will be
oh, okay.
Good, and well, we have a 10 gigabit connection to the data center, so that should not be the problem. Yeah, it should not
Well,
be
okay,
a
but
problem.
if you
But
actually,
it's not a redundant
have
connection.
your
So
company there, you work there, it's fair.
you wish.
no. I mean, it's
Okay, so you don't use that regular text save, so you have like a special one.
Little things that we
Yeah, yeah,
walk
yeah.
through and learn and adapt, and it's amazing how we get from we have absolutely no clue. Hey, now we know something. And now we know some more, and now we know something.
So the more you know, the more you realize how little you know.
So how does one work like on his local machine with a database of hybrid sites?
Yeah.
Okay.
Ja, nee, want ik ben dan ook niet toegeweest. Dat was dus van 10,5 dan is er COVID. Nu stel ik een eerste Meetup die ik zo doen van PHP community. Eigenlijk is het voor mensen ja, gewoon tussen die leren.
Ja, en dan meteen gewoon iets like
Ik ben er vanuit. Ja, ik wist niet, in een trein dat ik me niet wissel van de spreken tegen.
ja, ik werk niet zo heel ver hier van de kant. Nou ja, dat heb ik het met kantoor.
Heel erg hier.
Ja, 2 dagen in de week is de officiële dag. Maar is er veel village uit zien? Nee, dat ben ik aan niet boven. Maar ik kan er wel van in op zo. Als ik niet voor de feedback
Ja, ik
ja, voor wat staat er? Want het is niet meer in tract, hè, maar het is vergeet.
Infinite opportunity.
Ja.
Maar ik kan wakker liggen hoe dat wordt. Ja, dat is voor mij ook makkelijk. Dat kan ook niet in de week zijn. Rustig maar zitten. Ik ben eigenlijk wel tevreden, ja.
Finding where he has booked something very slow.
Ja, dat is de laatste dan waarschijnlijk in het.
Vraag me niet waarom. PHP is Vlaanderen? Nou, online dan waarschijnlijk komt hij wel waarom niet spreken. Waarom met vakjes? Ik heb heel lang met Spanje gewerkt, dus ik versta alles, maar ik ben weet gewoon heel lang dat elke
Ja, verstaan de branding en praten is iets anders.
allereerst dan daar voelde ik me veilig. Ik verstond me ook niet helemaal. Basically, the solution is to throw money at the infrastructure.
Ja, nee, maar dat is gelijk als ja, iemand anders hand heeft in te spreken, dan niet dat het figuur is dat niet de echte native die woord had.
Ja, check. Hello everyone back at home. You should have been here.
Okay, I'm gonna rally up the troops.
Can I ask everyone to take a seat? Grab some additional sandwiches for munching in between. Yes, for those who are sitting at home, we're having sandwiches and drinks and all the good stuff. So.
is even.
Okay, we're back for the second session, and Tess, you're going to talk about Varnish
Logging.
logging
I'm
with
going to talk
Varnish.
about logging.
Logging.
About HTTP logging. That's what I'm going to talk about.
All right.
Plain and simple.
All right. Let's show us how to log.
First of all, let me state the very, very, very obvious. I'm super excited to be back on the road again, back with the people. For the last couple of years, I've done like 25 webinars. I won't say I hated every single one of them, but at least half of them I hated. I don't like hybrid concepts either, so no offense to the people at home, but as I mentioned, there's space here. You should have been here. There's nothing like the real deal. There's nothing like actual meetups where you can eat sandwiches and win prizes. Because let's face it, people back home, you will not eat these sandwiches and you will not win the prizes. Enough of the banter with you. Of course, I am grateful that the people are here, but also that you're checking in and tuning in from home. This is not my first presentation anymore, so that means we're heading in a positive direction, right? I guess this is my 4th or 5th presentation of the year in actual real life. It's my 257th one, which also makes me very excited, and it's about logs. Very, very much about logs, not about these ones, not about these kinds of logs, but this very format. And let me get out of the way from the screen because, or am I out of frame? Yes, I'm out of frame. So Michael,
the book was in front
yeah. So should I stand here or am I free to roam around the room?
You're free to roam around.
Yeah, I'm all right.
See you until exactly.
Well, then this will be my fixed position. All right, ladies and gentlemen, this is what we call a log. An HTTP log should be quite common. Any idea what the official name for this kind of log line is? Any takers? None. This isn't going anywhere. So let's add a little bit of a cheat line here. NCSA common log format. And it comes with all the bells and whistles, the host and the log identifier and the potential authenticated user and the date, time, the first line of the request, the HTTP status code, and the number of bytes transferred. Now, any idea what NCSA stands for? Michelangelo knows, and he's going to grab a mic and he's going to tell you all about it.
Isn't that Netscape?
It's related. Here we go. Here's the cheat.
Oh, okay.
The National Center for Supercomputing Applications. And this wonderful organization came up with a web server pre-Apache in 1993 called the NCSA HTTP server. Very interesting. They, if you're first at something, you can invent things. They came up with the logs. They had first dibs on the log format, and that was a common format that you saw. There's also an extended format called the NCSA combined log format. Exactly the same information, but it also has the referrer and the user agent, all very useful. And today I came here to tell you that Varnish also supports this. Lovely. Varnish, for those of you who aren't in the know on what that means, it's actually a caching technology, and more specifically, a reverse caching proxy. So it's a proxy server, so it means it acts on behalf of either the user or the server. It caches. But the reason why we call it the reverse caching proxy is because it's not close to the user, it's more in the reverse direction. Because remember, back in the 90s when internet was slow, broadband wasn't really a thing, you needed to optimize all that traffic. So you put a proxy in your office. If you and your colleagues were going for the same image that would be super slow in loading, you only had to do it once. Only one person had to suffer. And thanks to caching, all that data was stored at the office side, at the client side. But then bandwidth increased, that problem disappeared, and as soon and every time, it's a sort of endless loop of suffering when it comes to optimization and performance. Every time you solve a problem, it's just taking away an obstacle, and you see the new problem facing. And the problem was that there was just too much bandwidth hitting these servers. So all of a sudden, you need to put a machine there and ensure that this little server doesn't topple over. It's also interesting because this Varnish server is in a unique position to capture logs because it sits on the edge, as we call it. And the edge is the outer tier of your content platform. That could usually be a caching server or a CDN or whatever. So it receives every single request. So it's in a really unique position. Now you saw that log format here. It's single line. It's relatively verbose. But Varnish captures a lot of data. Like this is all the output for a single transaction. And it can grow beyond that. This is just massive amounts of data that is available. It's like drinking from the fire hose. And that's what we're going to do today. That being said, hi, everyone. Good to see you. My name is Thijs. I'm the tech evangelist at a company called Varnish Software. Varnish Software is the creator of the Varnish Enterprise content delivery software that is used by some of the biggest websites in the world, some streaming platforms as well. People use it to build CDNs. And we're also the company behind the corresponding open source project called Varnish Cache. And joined together, we actually deliver solutions for about 9 million websites. And about 21% of the top 10,000 use the technology. So that's that. Also, just like Thomas, I'm available on social media as well. A variety of social media networks. For the sake of either giving me feedback, praising me, or heckling me right now, you can use Twitter. I'm used to that. I'm the author of Getting Started with Varnish Cache, which is an old book that I was happy to write in collaboration with O'Reilly. Now I have a new one. That's my What Did You Do During the Pandemic story. Well, I wrote Varnish 6 by example. I was tasked by my employer to write this one. It's quite a bulky one. It's a 2 kilo, 778 pager. It's I wouldn't call it a labor of love because it was a labor of lockdown, but I'm happy it's here. It's relatively complete, I would say. It has a very broad scope. If you're into web acceleration content delivery, you could win one of these tonight. That's right, ladies and gentlemen, back home. Only the people sitting here will win this copy tonight. We'll figure out a way to do this, right? Wim and Michelangelo will take care of it. I will leave this here, and one of you will go home. Well, everyone but a single person. You will not be going home with that book. Oh, yeah, you do. Someone else won it yesterday. So a little spoiler here. There's a little bit of an inside joke going on here. There's someone in the room that was at a meetup 2 days ago who saw this very presentation I delivered. So talk about dedication. But you did not win it, I guess. And you're still very much in the mix to win it, so apologies. Let's get back to business. So Varnish, I told you, is in a very unique position to collect logs. And the reason why it's in a very good position is because of the caching aspect. If you cache, then there will be no logs at the back end. So because that's the entire purpose, you want to protect this one from tumbling over. So you want to store data here and not use that. So I've seen a lot of these projects where people say my access logs are empty. Well, yeah, that's the goal. It's pretty much the goal to keep them as empty as possible. But then this has to act as a surrogate, so all the logs need to end up there. And all that logging information, and you saw an example with the little animation there, is super verbose. And we keep that in the Varnish Shared Memory Logs, the VSL. There's a lot of three-letter acronyms in Varnish, right? And they all start with a V. Very interesting. And all of that information is stored in what we call a circular memory buffer. It's like some sort of a FIFO buffer that is part of the Varnish D runtime process. It is 80 megabytes in size by default. So that means if that is full, well, stuff gets thrown out. It's FIFO, right? First in, first out. You can narrow it down to a megabyte at the minimum. I wouldn't advise doing that. And you can grow it to 4 gigabytes. The bigger you make it, well, the tougher it will be on the resources of the system. So 80 megabytes is good. If you need more, you can have more. And you can tune it via the -p runtime parameter. You can increase it to 150 megs if you care to do so. You can use the shorthand, -l. You can do it on the fly, but you have to restart your child process, which would indicate a couple of seconds of downtime. And then you have all this data, like firehose style data in the Varnish D runtime process, 80 megabytes of it. And using a tool called Varnish Log, you can drink from the firehose, which is kind of interesting. This is the command. If you run it, it comes with tons of options, and we'll walk through some of them to show you the vast capabilities of this logging tool. Now, I'm a big caching fan, so usually I always nag about caching, but today it's more about the logging aspect. And my message here is, even if you decide that you don't either care about logging or about caching rather, or you don't need it, consider installing Varnish at the edge of your content delivery platform just for the sake of the logging and the insights. So let's present some content. This is the first bit of data. I'm going to quickly do a sort of spoiler here. So this is what we're going to show for a single transaction. So just so you know, this isn't isolated. It's part of something bigger. It starts with a session. Any ideas what a session is? Please don't spoil it. You've seen this 2 days ago. Do not spoil it. A session. Is there a concept we can link this to that we know? And I see Mike grabbing the microphone. Mike is grabbing the mic. No takers here. Koen is going to give it a spin.
Connection between.
Yes, he knows, but you need to share it with the people who are not here tonight.
A connection between a client and
Yes,
Varnish?
yes, indeed, very, very much so. So a TCP connection that is opened, because one TCP connection can have multiple requests. What I see is if we keep this very interactive, there's going to be a lot of hassle. So we'll try. Usually, I live for crowd participation, but I see that it's going to get cumbersome after a while. Next time, we need to mic up every single one of them. So it is a TCP connection. It says so. You can't point laser pointers at LCD screens, unfortunately. You can't do that. This technology hasn't evolved yet, so I have to point with the index finger and say, it has a number. It has a transaction ID, and that's its unique ID. And then it has a begin tag. So all these log lines have tags and values associated with them. So you have a begin tag saying, hey, I am a session. The 0 means I have no parent transaction. So I'm the boss. I'm number 1 here. And what I'm actually doing is establishing something that resembles an HTTP1 connection. Then the session is open. You see where from and where to. So you see IP addresses. You see ports. You also see this HTTP label. It doesn't refer to the protocol. It's actually the name of the listening port. I can name it ABC123, and that would be listed. If you don't name your ports, they'll be numbered automatically, A0, A1, A2, and what have you. And then you have this unique timestamp, and 29 is the file descriptor. Then once you've opened it, you're going to open a subordinate transaction, which is a link. And that link tag refers to the next number. We're going from 89 to 90. And that is actually a request transaction. Why is that request taking place? Because there is an RxRec. We're receiving a request from the user. And then you close the session and you end. A little, we have a brief interruption here.
Yeah. Can you go back?
I go back.
Okay. I see IP addresses. IP addresses are personal identifiable information pointers.
That's the rumor, yes. That's the rumor.
Can you also make sure that in that logging you can masquerade those IP addresses?
I would say straight off the bat, probably not, but I can look into it. But my current answer, my uninformed answer is probably not.
Okay.
But that's a good one. So please remind me of that question so I can circle back to the people who developed this nice product and ask them about that.
Yeah.
Because that could be useful.
Yeah, especially because if you're not using the logging functionality for security purposes, then the personal identifiable IP addresses could be masked, maybe for the last octet or the 2 last octets.
It would be a great feature request. Let's make it one.
Okay.
I'll check. We'll do that. There are 2 releases of Varnish coming out each and every year. One on March 15th, so we missed that opportunity, and one on September 15th. So just after summer, we potentially could put this in, unless it already exists. So that's something we'll figure out.
Most of the times I think Varnish is behind a load balancer or like some SSL termination thing.
Yes.
So the IP you would see would probably be that IP.
Yes, but the problem goes beyond that, because eventually, and that's not related to this presentation, if you have multiple proxies, because Varnish usually doesn't sit alone. It sits either behind a load balancer or a TLS proxy, and you will get that IP. So you wouldn't be faced with that problem. But your purpose is to figure out who your original client is. So you're going to use all sorts of trickeries, like using the X-forwarded 4 header, or you're going to use the proxy protocol to deal with all of that. So eventually you will be faced with that problem, and we're going to have to deal with it. And for now, I don't have a solid answer, but I'll figure it out, and I'll come back with you with either a no, we don't do it, either a yes, we will do it, or no, we don't do it, but we're interested in making it better. So that's how we're going to go forward with this. Just again, that little word about these ports, that HTTP term that you saw right there comes from the fact that I named my incoming listening port HTTP. And I also have an alternative one called proxy, and I call it proxy because it uses the proxy protocol, which is a sort of protocol invented by HAProxy that transmits IP data, port data, but also TLV attributes from the TLS connection over a sort of TCP preamble. Again, very irrelevant to this context, but relevant if you're interested in using multiple proxies. It should be more adopted. It's adopted by us, it's adopted by HA proxy and other systems, but it should deserve a broader adoption rate. So let's get back. We went from sessions, we set up a connection, to receiving requests. Check out the verbosity of those logs. It's a beautiful thing to behold. So you see that we now have a different transaction called request. It's a request transaction. It has a number. As expected, it's number 90. We saw it earlier. Let me do that again. We see a link. It says we're going to open up 90. Well, here it is. It also has information about the request coming in, what port it uses, again, what listening interface it uses, some timestamp information, which will prove to be very useful later on because timestamps are marked everywhere. So it gives you an excellent opportunity to figure out how long it takes to do what. And you could filter on that. So we're looking ahead. Then every single part of the request is here. And then some internal stuff to figure out if you care about the caching bit, like which flow did it take? Was it what we can conclude here is we received the request. We see it as something that is cacheable. So we create a hash. And then we look it up in cache. We did find it, but we marked it as banned, meaning like we want this stuff out of the cache for reasons, and then turn it into a cache miss. And we fetch it. And what we do with the fetch is we open up a backend request, another transaction. We increment a number, that's another transaction. And that is the fetch going to our origin server that we're protecting and acting on behalf of. And the fetch itself, very interesting, took 0.002542 seconds. So we have all that information readily available. The individual fetch took the same amount of time. So we went from 0 seconds. So these are individual counters for the parts of the transaction. And this builds up over time. So we can see how long it took. And then you get the response. If you have a request, you get a response. And you have all this stuff very nicely written down. So we're dealing with a JSON application, sending us E tags, a specific content length. Because the age is 0, we can conclude that it wasn't stored in cache. If that age number increases, we can determine like if it's 5, it has been stored in cache for 5 seconds. Then also we deliver it. It's ready to be delivered to the client. We see that this number has increased for that part of the transaction, which increases the number to 0.002548. And we carry on. This is the final timestamp we'll announce. And that is the total time it took to generate that response. What's also interesting, by the rec ACCT, we're doing ACCT stands for accounting. So we're doing some request accounting. Conclusion here is that in the request, we had 73 request header bytes, 0 request body bytes because it was a get. Response-wise, and then the total is 73, of course. Then response-wise, we had 273 bytes of response headers, 567 bytes of payloads, which should, and let's see if that's true, that should match the content length header. And then you sum it up and you have 840 bytes being sent over the wire. Also, again, queryable, lots of information available. If you have a cache miss, so if you really need to connect back to that origin server, that request that led to a response will trigger a fetch that needs to happen. And that is a back-end request, as you can see here. And that is that separate transaction that takes place. So we can learn a whole lot from that as well. You can see the connections, the VCL that is used against some timers, the response that is composed, and then also some internal stuff like TTL. TTL means what time to live did we assign in the cache. At least we know it's cacheable. That much we know. And these are values from the headers. I don't really know these by heart right now, but we're using the RFCs and are caching it for 120 seconds. So we didn't override it into TTL. I think it fell back to the standard caching time to live of 120 seconds, and so on and so forth. So we're going to store this in memory. The storage device is called S0 because we didn't name it. And this is, again, the backend request accounting. So a lot of information. Now, we need to make sense out of all of this. I showed you a lot of text. Might not always be so easy to understand. But we went from a session to a request, client request to a backend request. I added a level of complexity because what we can have as well is from that client request, we can do sub-requests, ESI sub-requests. Very interesting material. And this is the hierarchy. I am dying to explain to you what an ESI request is because it's super exciting. This is an ESI tag. Are there any old schoolers in here who still remember SSI tags? Yeah. People who pretend to be the old schoolers don't look so old, but you may be experienced, and I'll give you that. It counts. So an ESI tag, just like an SSI tag, is a sort of placeholder, XHTML style, that you drop into your code or into your HTML, and Varnish will parse it. So will other CDN providers that support it, and will use it to, like, it's a sort of hole punching mechanism to cache things that otherwise aren't cacheable. So let's say you have this big page, you have this shopping cart panel and a login button. If that is uncacheable because of personalization, the entire page couldn't be cached, which is a pity. So through ESI, you can like make sure that little snippet is not cached, the rest is cached, and Varnish will assemble it as one page, whereas in reality, this is the header, and then the main page is the main page. And that resorts into a sub request being taken by Varnish if it inspects that. And you can see it here. So if we do varnish log, if we type varnish log and use -i to only include specific tags like the begin tag, we see all of this happening in a weird order. So to make it sensible, we have to start at the bottom for some odd reason. So we have the session, it begins. Then we have the requests. The requests, number 2, depends on one, is that one. Within the next part, you have a backend request taking place. But then you have this other request that depends on 2, which is an ESI request. And that hierarchy is very clear and visible in the logs as well. Let's simplify it a bit and just throw out the ESI, and then it will look like 1, 2, and 3. And the reason why this is so weirdly formatted out of the box is because we sort by VXID, by this transaction ID. We have 3 transaction IDs. But you can only drop something in the logs if you have terminated that action. So you start with opening up the session, but the session close happens all the way at the end. So that's why the session is logged at the end. The only thing we're very sure of that will be finishing first is the backend request. So that's why number 3 comes in first, then number 2, then number 1. So that makes no sense from a usability perspective. So what you can do is change the grouping. And that's what I would advise you. Here's an example. Varnish log -i begin, -g session. And then it'll make sense. You have proper indentation. The hierarchy is clear. Because of the asterisks, you can actually see at which level you are. So we start with a session. It has a request. Then it has that backend request corresponding to the request, an ESI sub-request, and a backend request that belongs to the ESI sub-request. And that's how that works. You can do -g request, and then we just, let's do a side-by-side comparison. We throw out the session context. No more session context. Easy peasy. Or if you do raw, there is no grouping at all. It's just as the lines come in. Remember, we're drinking from a fire hose. It can get very tricky real quickly. So there's only limited use cases where you want to talk about grouping raw. The one use case I can think of is if you filter on -i backend health. It's not tied to any request. It's just a probe that checks how healthy your system is. It will log that at certain iterations, at certain frequencies. But I won't be covering that. So in retrospect, for that part, use -g properly. I would say use -g session or -g request. I usually use -g request. I don't really care about the session context. So I think I've convinced you that there's lots of data in there, and there are tons of transactions, and they're tied to one another. They make sense to some extent, but what we want to do is we want to reduce the output. We want to ensure that it's easier. Like, okay, there's a lot of merit in getting a lot of data. Data is the new gold, the new oil, if you will, but it needs to make sense. And if you're drinking from the fire hose, maybe you want to do some rate limiting. Maybe we do not care about all the logs. I'm not a big fan of filling up disks with logs. Maybe we should take samples like this, -r 1 out of 5 seconds. So we only log once or keep one log line every 5 seconds. Could be a way of doing it. Another thing could be filtering out the tags. Maybe we do not care about all the tags. Maybe from these transactions, we just want to display the tags we're interested in. As indicated here, maybe we're only interested in the client-side transactions. Client-side in Varnish context means the request and the response, not the backend request and the backend response. We only care about the client. Maybe we only care about all the rec-related, all the request-related fields. And also the timestamp, of course. Cool thing is you can use globs here for matching multiple ones. You can also use lists. So you can do it at the backend side, and then the context changes from rec to brec. And this is it. This is the result from this one. We care about all the log lines that start with rec and the timestamp. And this is what you get. So it gets easier. It's not super easy yet. Maybe this is not the data you care about, but it gets easier. You can also do lists. So you can see here that I have multiple -i tags, but you can also use commas to separate them and combine them with glob tags and what have you. You can also use -x from that gather pattern that you have here to just exclude things. So -x has the same properties, multiple ones, you can chain them with commas, you can use glob patterns. So you're very flexible in exclusion. Here's one I use a lot. Maybe we don't care about all the rec header entities. We don't care about all the headers. Maybe only the ones that match this regular expression. So we only care about the accept language header, which is a useful one to know about. We can also exclude based on matching tags. So we care about all the response headers except the ones that start with X's, because those are probably custom defined ones and not RFC related headers. And that's that. So what we've done so far is we've compressed the output quite a bit by only taking out the fields that we care about. But we need to crank it up a notch, because maybe instead of having all the transactions and limiting the output from all these transactions, maybe we do not want as many transactions in our output. Maybe we want to take it a bit slower. And VSL queries are a query language that are based on record selection criteria, operators, and operands. To make it very clear to you, here's a very concrete example. We want to have all the logs only if the URL equals /, so only the home page we care about. And that will narrow down your data set quite a bit and will make it a lot easier drinking from the proverbial fire hose. Let's talk about these record selection criteria for a minute. So that field has a lot more syntax to it. We can have levels and tag lists and prefixes and fields. Let's throw in a little example before everyone falls asleep. This one, for example, we care about timestamps. We want to match timestamps, not just any timestamp. Timestamps that relate to the response. If you pay close attention, that's the last kind of timestamp we log. That's like the total time it took for the transaction to be processed. And we care about the second field. And we don't care about it for every single request. We only care about it for level 2 and above, which means sub-requests. One level of ESI, you could have like an ESI and an ESI and an ESI. That's a level higher than 1. That's what we want. And that's what you get out of it. So the timestamp format, so this is the label itself, and we have 1, 2. So the time since the start of the unit of work, that increments, that's the total time. Not the time it took to calculate the response. No, the total time it took from receiving the request to actually outputting all of it. And that's it. So blue is the timestamp. That's the tag. The field is resp. The matching value is resp. And then the field we want is this one. So this means, and now we can throw it into something that actually makes sense. We want to get the request URL and the response timestamp for every single request that happens at the second level or more, so ESI sub-requests, where they took longer than 2 seconds to load. So all of a sudden you have this advanced querying language that you can use to filter out specific things from the logs that you care about. Slow things are interesting, in my opinion. You want to filter them out. This is one way of doing it. I do want to showcase other operands as well. We do double equal for numerical comparison. So we want to filter out everything where the backend responded with a 500. 500 is pretty bad, so we do want to know what went on there. We can do other kinds of numerical comparison as well, as you know, as you're probably familiar with. And we can use tildes, which are interesting in their own way because they're an operator used for regular expressions. So you have this Perl-compatible regular expression sitting behind here. So that means we care about every single URL that starts with contact, but maybe it could be contact and then anything else behind it. So we match multiple URLs. We can also exclude certain things. We care about everything where there's no accept language header. We care about browsers that don't send accept language headers. And then I added equal and not equal for string equals and string not equals. They're not the same as double equal or not equal. So it's NE and EQ. Bear that in mind. Let's throw a little example. So I wanted to reduce the amount of crowd participation, but this is a good one for crowd participation. We need to have this at least. So dear people, at home and here at lovely offices of Cube, what is happening here? What are we looking for? Mike is grabbing the mic, so who's feeling brave? No one. I see blank stares. People want to avoid this. But I see Koen. Koen is up for it. All right, Koen. Let's go. Let's take it from the top. What are we looking at?
looking at logs for requests where the content type is an image.
So we're looking for images. That could be an image JPEG, image PNG,
TIFF.
image SVG plus XML, TIFF,
Bitmap.
whatever. Everything that has image in the content type.
And I'm gonna go out on a limb here and say that the image itself would be bigger than 2 megabytes.
Yeah, it's good. That's the lazy megabyte notation.
Yeah.
So we're looking for logs where we have images that are larger than 2 megabytes. We want to filter those out. And what we want to know about them is their URL and their content type. So that's a way of doing it. It's quite interesting if you ask me. So that's body bytes transmitted. So that's rec ACCT5. So 1, 2, 3, 4, 5 body bytes transmitted. You can also, if you want to know the size of the headers, you can do that as well. But the body size is what matters here. You can also chain them, of course, or you saw not already. So there's ways of grouping this together. Here's another example. We want to find all the transactions where when it gets stored in the cache, it is deemed uncacheable in the TTL tag because, not just any uncacheable data, because a cookie was either set, so setting cookies implies state changes, so we can't cache that, or there was private no cache or no store in the cache control header. So you can chain all of that stuff up. I think it's pretty clear by now that the VSL queries are extremely powerful. Okay, so until this point here, we talked about logs as they come in. I repeat it. Got a bit tedious even, drinking from the fire hose, yada, yada, yada. It is as it comes in. But what you can also do is dump the buffer. So that means if you do -d right here, instead of looking at the new lines coming in, you can look at that, what is 80 megabytes default. What's in there? It's a lot. Could be a lot of text. And you do that for specific reasons. Like one of the reasons could be you want to filter on a timestamp. So you want to say, I want all the data since May 10th, 11 o'clock UTC. And then all the data comes out. So you can do a little bit of an experiment. One of the questions that was asked 2 days ago when I did this talk for the first time was, yeah, but it's memory. It's a circular buffer. What if you're looking for stuff that's not in there? Yeah, that's indeed a bit of an issue. So either you increase the size of the memory buffer, or, and that's a transition, you read or write the disk eventually. Some might say that's a good idea. I'm going to argue with you that it very much depends on the traffic patterns and the size of your disk and the dimensions of your hardware and the power of your disk. If you have an NVMe SSD disk that's pretty fast, maybe you'll cope. So what you do is varnish log -w writes the data in a binary logging format, the original binary structure, to disk. By adding the -a lowercase parameter, we can append. Otherwise, it would continuously overwrite the file. Now we're appending to the file. If you have such a binary log, you can replay it. You can do varnish log -r, and it will run it again. And then you can inspect what was going on. Back in the day, you could use these logs with the varnish replay tool to actually replay those logs and heat up the cache, warm up the cache. That no longer exists, unfortunately. That got slashed many moons ago. So that's one of the reasons why you would do that. So you can look into it later. It's a bit more compact. We did a little bit of a test yesterday, very poorly from a statistical point of view. We ran some logs in there. We counted the trees, stopped the transaction, did it again with -a uppercase to have it in ASCII format, and notice the difference. It was double the size, which didn't seem to impress a lot of people. So double is not enough for folks. So I would say if you're interested in looking at those logs at a later time, ASCII format is nice. If you want to use it in varnish log, well, do it as so. But keep in mind, it could be a lot and a lot and a lot of data. So be careful with that. So I have an alternative for that, an alternative solution. Maybe we switch from varnish log to another tool, varnish NCSA. And the clever folks sitting here and back home, I've already hinted what NCSA means, and it's similar to varnish log, so it will present this. Varnish NCSA will take all that logging information that is crawling around in that circular memory buffer and will present it as a single line using a specific format. And you can write that to disk in this way, -a, -w with varnish NCSA, and it'll be single line output. Could still be a hell of a lot of output, but the data set is heavily reduced. And this is the format. It comes with a formatter. If you've studied NCSA well, Through the slides, you will know that we have a host, which could also be the client IP, of course, the log identifier, the authenticated user, the timestamp, the request, the status code, the bytes transferred, and then you have this structure of fetching headers. So if you use these curly braces and I, you'll be getting request headers, any request header. But because we're respecting NCSA formatting, we're going to go for refer and user agent. But the sky is very much the limit, ladies and gentlemen, and you can fetch a lot of things. The table goes on and on and on. Things I find interesting, as you've seen, this format with I gets you the request headers. With O, if you would add an O, would be the output. You have in, you have out, would be the response headers. And I like this one as well. This one, X, will get you VSL tags. You can display specific VSL tags or internal varnish variables. I'm going to throw in an example. We're extending our combined log format, and we're adding sides to it. Like out of the gate, straight out of the gate, you only get client-side logs. So that means whatever happened at the back end, we don't care about that, because the context is we're trying to replicate the behavior of our server that we're offloading. But by adding -C and -B, you get both transactions. If it would be a miss or a bypass, you will get the other transaction as well. And we're displaying the side, at which side it happened. And you can see B stands for backend and C stands for client. It's a bit of an edge case, but I wanted to show you that there's internal variables that you can just display. You can also mix it up a bit and say, I do not want to respect any of those formats. I just want single line output to my own liking. And I'm just going to display the URL, the internal cache handling, and the sides. So that means if we go start at the top, /test is irrelevant in terms of hits or miss because it was actually a backend call. So it's the result of that cache miss at the client level. This one was a hit, so there's no corresponding backend one. And this one is also a backend transaction because we bypassed the cache deliberately. All that info is there. You can also query. You can figure out, in this case, all the timestamp where the backend response body, what do we want? We want the timing when we compose the backend response body. We want the second field, so that took 2 seconds, and we want all of them where the backend response body is larger than 1 second. So we want the host name, the URL, and the timing for everything that was slower than a second to fetch from the backend in a single line output format. So all of that is possible. We're almost nearing the end of the session, so I want to say, if you run this in production, you probably want to demonize it. You don't want to run it on the foreground. It's a service that you will run, and you can use -D to demonize it, and you can use -P to store the PID ID. But, ladies and gentlemen, you probably use systemd on your system, and it has you covered to some extent. The main PID is here. It has an exec reload command, so if you do systemctl reload varnish, it will do a hop on the main PID that it takes care of itself. And if you use the official packages from Varnish, the ones we provide, you'll have a standard NCSA system ready to roll. Just need to do systemctl enable varnish NCSA, reload the service, and then we will take care of it and store all that information here. One thing you need to do, however, is take care of log rotation, because as mentioned, these things could get really big. So here's an example of a log rotation where we keep 7 logs, we rotate them daily, we compress them, and we do a post-rotate command to actually like reload the Varnish server so that it releases the file and grabs a new one. And you'll end up with things like this, where you have the plain one, and the first one that is archived, and then all the gzip ones. Last but not least, let's go. So we started in the beginning. We had a little bit of a build-up going on. We went from the hors d'oeuvres to the main dish, and now we're at the dessert, which is Varnish Top. And Varnish Top, as the name implies, it's very similar to Top on Linux. It lists the top transactions, and you can do pretty much anything with it. Please don't run Varnish Top without any attributes, because it would just run the most popular tags, the tags that are used most, and will make no sense. But if you start including like -rec URL, you will get the most popular, the most requested URLs. In this case, it's contact. It gets requested 31.76 times within the interval, and the interval is a minute. So that's the frequency. You can do all sorts of stuff. You can say, I want the most popular cache misses, or I want all the URLs of the most popular transactions that bypass the cache. I want to know everything that's uncacheable, or I want all the URLs for pages that have a loading time larger than 2 seconds. And you can see it. Maybe you can do a little side-by-side comparison. What's the most frequently used protocol? Well, it's a landslide victory for HTTP 1.1, apparently. And you can do the same thing on begin SES, where you can see that plain HTTP wins over the proxy protocol. Quick explanation, the proxy protocol is used to offload TLS, so there's probably TLS proxy in front of it, so that means this is HTTPS. And if that isn't really satisfactory enough for you, you can define custom VCL tags if you want to. And you can do that through the prolific Varnish configuration language. It's an amazing feat. It's still the unique selling point of the open source project. And you can use a module, the std module, and call it std.log, and then log a string. And that will end up in the VSL, which is kind of cool. Here's a use case. We import the std vmod as well as the vsthrottle vmod that allow us to throttle incoming requests. And we allow every client identified by its client IP to only do 15 requests every 10 seconds. If you exceed that, you'll get blocked for 30 seconds. And that's when we start logging. std log, and then we use this rate limit semicolon, or colon rather, it's not a semicolon, colon, because then by using that format, you can filter on, I want all the VSL logs that start with rate limit. And then you can say, that client is blocked for another X amount of seconds. And you use std log, and this is what it's going to look like. So you can filter on it. You can say, I want to group it by request. I want the request URLs, and I want to include all the VSL log tags specifically about rate limiting. And you can see that this client IP, again, Mike, sensitive data, IP addresses, we'll take care of that next time around. This is my second run I'm doing this presentation. Maybe, if I'm allowed to do it the third time, there won't be any IP addresses in there. But it's blocked for another 29 seconds. That's it. That's all I have. 40 minutes in, I can do a demo, but I think people care more about sandwiches, drinks, maybe watching some TV if you're back home. But I still have a book to raffle, so I think we can conclude this session, maybe go to the raffling bit. I thank you for being here. I always enjoy speaking, and I hope to see you back again real soon to talk about another subject. Are there questions?
Yeah, I see also people typing in the chat. My question is, because the Varnish log is a fire hose, means that the log is basically streaming. What kind of backend tools for analysis are being supported by Varnish? Is that only the commercial ones like Splunk and
well, I have seen an integration with Logstash as well.
Mm-hmm.
Where that Logstash, because the shared memory is not remotely open, so you can't really come in via TCP/IP. So you need some sort of agent that runs in locally, and that runs the Varnish log command, gets the output, and stores it. I haven't looked into such great detail for the logs as such. Mm-hmm. There's plenty of ways, like when you talk about statistics, which is another presentation, we know that there's integrations for things like Prometheus, but here I would stick to Logstash. I know it has a good agent. I should check if there are beats for that by Elasticsearch, like file beat.
Yeah, well, you have Logstash, you have Loki from Grafana, you have, as you mentioned, Prometheus.
I do know there's a plugin for Logstash that allows you to take certain values that you care about, and then you centralize them, and then you can unload whatever you want to unload.
Yeah.
But my wish, it's on my wish list, I'm not sure if it'll ever be built, is have a sort of command like Varnish log remote where you can do like distributed calls across, but it's very resource intensive, and that's the one thing we don't do. We never compromise on performance.
Okay.
So if it would have the slightest performance impact, we just won't do it, because that's our main responsibility. It's very nice to have cool analysis tools, but if it takes us away from our main goal, our main objective, then we won't do it.
Okay, all right, makes sense. I'm looking at the people in the chat. I saw people typing, but I don't see any questions popping up. Anyone have questions here?
The next question will be, when can we have drinks? And the answer is soon.
Okay.
Thank you, everyone.
Thank you.
Always a pleasure, always. And thank you for people back home. I hope you realize it was banter. If you feel insulted, my apologies. I'm actually most of the time a nice guy in real person, in real life rather.
We can confirm. lot of applause from the audience back home. So
all good. Thank you.